All right, today's lesson is called 5-2, Relations, Domain, and Range. So get out your notebook. Let's take some notes. There's going to be several examples today. So a relation is a set of ordered pairs. Write that down. A relation is a set of ordered pairs. Two numbers that relate to each other. Relations can be expressed in 4 different ways. As an ordered pair, also as a graph, as a table, and with mapping, and we'll show you what those are. So be sure to write those 4 down. All right, example 1. I want you to draw the examples. So this is going to take a little bit for these notes. You're going to need to have a coordinate plane, and you're going to need to draw these points on a coordinate plane. And this says, example 1, represent the relation shown in the coordinate plane as a set of ordered pairs, show it as a table, and then use mapping to show each point. So what we're going to do is we're going to write the ordered pair for each of these points for A. 0, 0 is the first point right there. 2, 2 is the second point there. 4, 6 is the third point. This point is negative 5, 1. Negative 3, negative 2 is the next point. Negative 2, negative 5 is right there. And the last point is 5, negative 2. Those are the ordered pairs represented. And then if we want to make a table, we would list each x and y. So x would be 0, y is 0 for the first point. Then 2, 2, 4, 6, negative 5, 1, negative 3, negative 2, negative 2, negative 5, and 5, negative 2. So you need to have this table. So then we can also show this as a mapping. That's C. Mapping, you want to draw these little ovals here, and you're going to list your x's and y's, and then you're going to draw an arrow to connect an x with a y. So let me show you. First, you have 0, 0. So then that ordered pair goes together. Those 2 points go together. Then you have 2 and 2, which is there. Then you have 4 and 6. So you're mapping them by drawing arrows from an x to a y to show that they're related. Then you have a negative 5 and 1. Then you have a negative 3 and negative 2. Then you have a negative 2 and negative 5. And then you'll see your last point is 5, negative 2. So here you have a 5, and it will go, since you already have negative 2 listed, you will draw an arrow to the negative 2. And that's called mapping. So again, you can express a relation with a coordinate plane, as a set of ordered pairs, as a table, and using mapping. Okay, and now we have some more words that we want to write down. The domain is the set of all the first coordinates, or all of your x's. So the domain is the set of all the first coordinates. In other words, all of your x's. That is the domain. The domain in example 1, you would just list all of those, and we usually do that little swirly thing, and we're just going to list them. So 0, 2, 4, negative 5, negative 3, negative 2, and 5. So you're listing all of your x values. And you don't repeat them if you have more than one. Okay, then the range is going to be the set of your second coordinates, which is your y's. So the set of your second coordinates is your range, and that would be all of your y values. The range in example 1, again, we're just going to list all of the y's. Oh, that's horrible. Okay, 0, and then 2, 6, 1, -2, and -5. And notice -2 here is repeated, so I only list it one time. Alright, so that is domain and range. Domain is your x's and range is your y's. Alright, the next word that you're going to have in your notes is a function. A function is a relation in which none of the first coordinates repeat. None of the first coordinates repeat. So all of the x's, x values of your function are different. All of your x's are going to be different. Alright, so examples. This is example 2. It says state the domain and the range, then determine whether or not the relation is a function. So the domain, you're going to list all of your x's. So I have a 2 and a 3 and a 6 and a -1. And that would be my domain. The range would be your y values. So your range, your range, if I can get it to work, your range will be listing your y values. So you have a 4, and then we have a 5, and then we have another 5, so I'm just not going to write it twice. I'm only going to write it once. And then we have a 3. So that's going to be your range. So is this a function? Well, it is a function because none of the x's repeat. So that means yes, it is a function. Let's do the same thing with example 3. So here we're going to list the domain and range. So the domain again, list your x's, 1, -2, then 1 again, then -4, and 2. So 1, -2, -4, and 2 are going to be your domain. And then your range is going to be your y values. And your y values are your second coordinates. So you're 9, 5, 6, -3, and 8. So the question is this a function? Well, no, it's not a function because you can see 1 repeats. So 1 is with 9 and 1 is also with 6. And your x values can only have one y. Alright, let's go on to example 4. In example 4, it gives you some mapping. This is called mapping here. And it says express the relation shown as ordered pairs. Then you state the domain and the range, and then if it's a function. So first we're going to do the ordered pairs. So this 2 goes with 12. So 2, 12 would be an ordered pair. And the 2 also goes with this -3, so that would also be an ordered pair. Then 1 and 5. And then 0 and 0. And then this -1 goes with that -5. So -1 and +5. So those are your ordered pairs. Now your domain is where you list all of your x values. So I have a 2, a 1, a 0, and -1. That's pretty easy. And then the range is where you list your y values. So you're just going to list a 12, 5, 0, and -3. And then is this a function? Remember, each x can only go with one y. Well, this x over here is going with two y's. So it can't repeat. So because the x repeats, and you can see it repeats here, there, and there, so is this a function? No. Alright, we have 5 more examples. You're going to need graph paper, so I would go ahead and get some graph paper ready because you are going to be the next 5 examples. So here we go. Number 5. It says find the domain and range. So you should plot these points and then you need to find the domain and range for each one. So for number 5, plot these points and we're going to find the domain and the range. Now remember, the domain is all of your x values, and the range are all of your y values. So let's go ahead and see what these ordered pairs are. So on the paper we're going to put our ordered pairs. So this one is -5, 5. This is -8, -7. That is -1, +2. 4, 0. And 8, -5. So what we're going to do is list all of the x values that appear on this graph. So all of the x values would be -5, -8, -1, 4, and 8. So that's your domain. Then you're just going to list your y values, and your y values would be 5, 2, -7, 0, and -5. And yes, you can list them in order if you'd like. So that's your domain and range for 5. All right, for number 6, you're going to want to draw this line, and notice that you have dots at the end. So let's go ahead and draw this on your paper. All right, so you have -8, 1 is the beginning, and 2, -4 is the end. This is a line segment. Okay, so the line segment, the domain is you're going to list every x that would appear on this line. Now it starts at -8, so the way you do that, remember this is your x, and that's your x. So your x values go from -8 all the way to 2. So the way you write that is your domain starts with -8, and then it ends with 2, and so your x values are in between and included in -8 and 2. Now because this has a closed circle, that means -8 is included and 2 is included. So x is going to be greater than or equal to a -8 and less than or equal to 2. And that's how you write the domain. Now let's look at the range. You can see this is your y value. Your y value begins with 1 and ends with -4. So we're going to write it the same way. So x is in between the 1 and it includes the 1 and the -4. So x is greater than or equal to 1 or less than or equal to -4. Actually, I have to write that backwards. So let me erase that if it will let me, or I'll just mark through it. So this one is wrong. Okay, notice the -4 needs to be over there because -4 is smaller than 1. So you have a -4 here, and then you have a 1 here, and I also used x, which is wrong. So I'm going to put the y in between. So now the y is greater than or equal to the -4, which is there, or it's less than or equal to 1, which is up there. So the y's are kind of written backwards. All right, may not understand that, so let's keep going. Now on number 7, again, plot this on graph paper. Notice here that we have an open circle, open circles and closed circles. Whenever you have an open circle, that means that the value is not included at that point. Whenever it is a closed circle, the value is included at that point. So let's see what these points are. All right, so the open circle is here, and it's at -6, -2, so write that down. And then this closed circle is at 4, 6. So we have a line segment that goes from here, 6, -2, up to 4, 6, with a closed circle at 4, 6. So the domain, remember, is going to be your x values. So your x begins at -6, but it's not included. -6 is not included, and it ends at 4. So your x values are greater than, but not equal to, -6. And it is going to be less than or equal to 4. So that's going to be your domain. Your y values, so let's look at y. So here's your y. It's at a -2 is the lowest, and then a 6 is your highest. So we're going to put the -2 here because it's lowest, and the 6 there. And your y values are going to be in between. So y is going to be greater than, but again, not equal to the -2 because of the open circle, and it's going to be less than or equal to 6. And remember, the x's, a line segment is made up of points. So this is just a bunch of points that are all right next to each other on this particular line. So any x value that's between these two, -6 and -4, are going to be on this line as long as they're associated with these y's. All right, let's try number 8. Okay, draw this on your graph paper. Notice that we have 2 open circles now. So that means this is a line segment, but these 2 points are not included on that line segment. So we're going to list the domain and the range. Start by plotting these points to see what points they are. All right, the first point is -3, -1 here, this point, and the second point is 5, 3. So the domain again is your x values. So here's your x's, -3 and 5. So the domain begins at -3 and ends at 5, and your x values are all in between, but they are not included. So the symbol you would use is -3, x is greater than -3 and less than 5. And then for your y values, your y values are here, the second. So that's -1, and it goes to 3. So you would put a -1, goes all the way up to 3. Your y is in between. Again, y is going to be greater than -1, but not including it, and less than 3. All right, the last 2. For number 9, notice now this is a ray. It's not a line segment. It begins here at this point, but then it goes on forever. That's what that arrow means there. So let's see how to do these. Start by listing this point. All right, so here you have -3, 2, and that's the only real point that you have at the beginning because there's no point at the end. So this is your x. So if you look at your x, you're going to put -3 here. So that's what your x is. Now, you're looking at points that are on this particular line. So if I look at a point that's on this line, I look at, here's a point. So this point is on the line, and that point is -1, 0. And then I look at another point, let's say this, and this would be 0, -1. And then I could go down here, I don't know, I can't see where it would cross evenly. But what you're noticing is as you are going along this line, the x's are getting bigger. So this point, is here. This point is going to be where x is 1. This point is going to be where x is 2. This point is going to be where x is 3. This point is where x is 4. So your x's actually are going this direction. So your x's are going to get bigger. So x has to be, and notice you have a solid point there. So x is going to be greater than or equal to a -3. And that's your domain. So the x's on this line will always be bigger or equal to -3. Now let's look at the y. So for y, your y is 2. So what's happening with your y values? Okay, as you go along this line here, are the y's getting bigger or are they getting smaller? So if you look at your y's, let's see, at this point your y is -1. At this point your y is -3. Then there's -4, then there's -5, and then there's -6. So your y, it's going down. So that means the y's are less than or equal to the 2, because this is the highest that the y is. So the y is going to be less than or equal to 2, because as you go down, the y's will get smaller on the ordered pairs that exist on that line. Let's do the last one. Okay, so this point is -5, -2. And this -5 is your x values. So this is not included because it's an open circle there, so -5 is not included. So I'm going to put a -5 here. Actually, that's not -5, that's +5, so my bad. Because you go over to 5 and down to 2. So that's a +5. So on this particular line, what we want to know is as we go this way on this line, does your x values get bigger or smaller? So we start at +5. Then notice here, this is where x is 3. This is where x is 1. This is where x is 0. So I'm going over every time. So I'm going to the left with my x's, and when I go to the left with my x values, they get smaller. So that means x is going to be less than +5. Let's look at y's. So the y's begin with -2, and again it's an open circle. So now we have a -2. So we just need to know what's happening with our y values. So our y value here, this is -2. Here, this is where y is 0. This is where y is 1. This is where y is 2. This is where y is 3. This is 5. So as we get bigger this way or go up, your y's get bigger. So that means y is going to be greater than -2. All right, I know we're going to have questions on this, so you want to write down a whisk. When and where did you watch it? Summarize what you've learned about domain, range, functions, mapping. Just summarize that whole thing. And then also, what questions do you have? All right, this was a little bit longer video, but hopefully it's helped.